Hello and welcome everybody to today's Association for Manufacturing Excellence webinar series titled The 5 Principles of Lean, a 4-part introduction to lean thinking. Today's third webinar in the series is titled Let the Customer Pull. I'm Dave Desker, Vice President of Marketing at AME Canada, and I'll be your moderator. Today's presenter is Richard Evans, the President of JR Lean, VP Programs East for AME Canada, Chair of the Lean Certification Oversight and Appeals Committee, and a Training Within Industry Certified JI and JR instructor. Richard has spent the past 4 decades helping companies become more effective in delivering quality and value to the production process while focusing on customer success. Having a manufacturing engineering background, Richard helps organizations to recognize waste through mentoring, coaching, and applying lean principles, tools, and techniques. His extended knowledge of various industries, including automotive, aerospace, railroad, packaging, food processing, printing, and fasteners, have enabled him to quickly focus in on opportunities for improvement. During the past 10 years, he has assisted companies in developing lean transformations and has facilitated over 50 Kaizen events. Before we start, just a couple of housekeeping items. You'll be in listen-only mode throughout the webinar. You will see that you are muted on your attendee panel on the right side of your screen. If you have questions during the webinar, please type them into the question area in the attendee panel and click on Submit. We'll review the questions at the end of today's presentation and answer as many as we can. When you log off today, please check your email inbox. There'll be an invitation and link to fill out a short webinar attendee survey. Please take a few minutes to complete the survey today, as your feedback is very important to us to improve future webinars. Richard has also graciously agreed to provide a PDF of today's presentation. We'll be sending that along with a recorded link for a webinar replay to each of you next week. Now I'm pleased to introduce Richard Evans, who will present Let the Customer Pull. Take it away, Richard.
Thank you, Dave. Good afternoon, everyone. Good morning to our colleagues that may be out on the West Coast or somewhere else in the world. Welcome to part 3 of our 4-part series, the 5 Principles of Lean. If you were lucky enough to join us for the first 2, you've learned about value for the customer, you've learned about value stream mapping, and you've learned about workplace organization, all of which will help you establish a good foundation when it comes to removing waste from your processes. Today's session is part 3, Let the Customer Pull. So what do we mean by let the customer pull? Well, essentially, when we make a product, we make it according to an order or a demand from a customer. And that's really the only reason that we're in business, is to make money. So we manufacture that product or provide a service, if you're in the service industry, in order to drive value for your customers so they will pay you. When we say let the customer pull, essentially what we want to do is to try and time our manufacturing or our service in line with what the customer demands. So if they demand X number of products per week, we want to try and manufacture X number of products per week. So in order to show you a little bit about pull, we're going to have a 2-part session today. The first part is going to be on an acronym, SMED, S-M-E-D, and the second is going to be on Kanban. And we'll talk about both of those as we go through. So sit back, relax, enjoy. We're going to go to the movies today, and you're going to see a couple of videos, and hopefully it won't be too jerky for you. But remember, we're sharing this across the nation, both US and Canada, and the networks have a little bit of delay in sometimes. So sit back, relax, and enjoy the next webinar. So part 1 is SMED, So what is SMED? Some of you may have heard it before, but let me just introduce you to what SMED is through a short video. So there was a remarkable difference between the two there, a remarkable difference. And essentially, we're talking about what setup reduction is. So single minute exchange of die is the SMED is the acronym for single minute exchange of die, or setup reduction, or quick change over. So if you had a look at that video showed the difference between 1950 and 2013 and the time it took to actually have a pit stop. And we'll talk about the video in a second, but really, if you're running a production process and you don't have a piece of dedicated equipment, then you have to finish a current run of production, and then you have to convert that machine. You have to change it over and reset it up for a brand new part. And the time when you finish producing your last piece to the time when you're actually producing the second good piece of your next batch is called changeover time, or setup. And as you can see from the screen, it is the non-value adding setup time that we're trying to focus on. When we're actually manufacturing parts, we're in the green. So we're adding value. We're changing the form, the fit, or function of a product in line with customer requirements. So that's green, that's good. But the time from when you stop producing that part to the time when you're actually starting to produce the second piece is non-value added, albeit that the machining time of the first piece of the new batch is still value added, but it's extended because you probably take a little bit more time in doing that to set tooling and things like that. So where does single minute exchange of die come from? If you think back to the times when automotive was mass production, you've got presses that in fact have huge dies. They're the same size as some of the rooms that you're sitting in now, or even bigger. And to change that die, male and female die, to change it took quite a lot of time. It could have taken maybe 48 hours to change. So the consequence of that was that an enormous amount of inventory was produced in order to offset the cost of the changeover. But that enormous amount of inventory held dollars and space, and then you had to move it, you had to store it, and there was possible damage that could have occurred. So the original thinkers, thought leaders, said, we're going to challenge you. Instead of 48 hours, we want you to change these dies in less than 10 minutes. So we want you to do them in single minutes, 9 or less. And the methodology they used to go from 48 hours down to less than 10 minutes, they termed SMED, or setup reduction. So that's a little bit about what it's all about. But what does it give you? So these are the benefits that you get if you can reduce the changeover time. Obviously, shorter setups means that you have more frequent setups. And if you only do a setup once a week, you don't get much practice at it. But if you do a setup every hour, then you'll start to see some of the benefits and some of the improvements that will come through repeated practice. You then are enabling smaller batches, because the changeover time now, if you do standard costing, which unfortunately many organizations still do, then the price piece per part, if the setup is very small, comes down, and you can run much smaller batches. If you've got smaller batches, then you can be extremely flexible with your production, and your lead times through your organization will now become very, very short. And if you have shorter lead times, then you can achieve much more customer satisfaction, because customers tend to change their mind frequently, and you become more responsive and gain a competitive advantage. So we watched the Formula One race car example, and I believe it was actually around 67 seconds that they took to change the four wheels and add more fuel in 1950. Now, it takes about 2 seconds. Back then, they had 4 assistants helping. And I think that was all they were allowed back then through the competition rules. Right now, 21 assistants. But the labor is not where the cost is. The cost of your product is actually in how long it takes you to make it through the factory. So the value-added portion is extremely small of the time that it takes to make a product. So it's not labor that really adds cost. So what made the difference? Well, setup reduction or SMED. So in order to reduce your setups, you need to go through a 4-step process. If you think about the first slide that we looked at, where the red was the non-value added, our objective is to capture that current situation. Step 2 is then to separate what we call external from internal. And these are the elements that you've got that make up the changeover. So what do we mean by internal and external? External means that you can perform that activity while your machine is still running on the current job, or it's running on the next job. So anything at all that you can do while the machine is still running, do it. Internal means that it can only be done when the machine is stopped. So step 2, you want to convert or separate, external from internal. The next step, step 3, is to look at the elements that you currently consider to be internal and can only be done when the machine stops, is to see whether you can convert those to external elements. And then finally, step 4, what you've got left, there is still a lot of waste within that internal element process that you can now eliminate. And we'll give you some tips on how to do it. So step one, capture the current situation. A video is worth 1,000 pictures. And unfortunately, some organizations try and steer away from using video in the shop for many different reasons. But if you want to capture the process 100%, then you really need to videotape it. So if you have maybe employee objections or anything like that, then as leaders you need to discuss with the employees the reason why you're going to videotape the process, and that you're videotaping a process, not a person, and that particular videotape you can blank out faces if you need to. Once you've videotaped the process, you can then document the elements, each element, as you go through watching the video step by step by step on what we call a standardized work combination table or a setup reduction chart. I'm showing a standardized work combination table here on the screen. And in this particular one, we're using like a Gantt chart methodology to show the elements. And in the other one, we're using a bar chart to show the elements. One actually shows like a Pareto, where's the longest. The other one shows the sequential and the duration. So capture the current situation. That's your first step. Step two, you have to separate internal and external elements. So for each element, each line item that you have on your standardized work combination table, look at each one of them and agree whether that could be done, whether the machine is running, which is external, or whether it has to be done when the machine is stopped, which is internal. So here are your descriptions. Internal, any work element which cannot be carried out safely unless the machine is stopped, tool changing, material alignment, etc. And external, any work element which can be safely carried out while the machine is running. Preparation of tools, tool kitting, preparation of gauges, etc. The two types of element should be documented using colors. So red for internal and green for external. And then create a chart like we've seen to show the impact on setup time, such as this. So this one in the top left shows that there are quite a number of elements in there that are green that you can actually do while the machine is still running. So at the bottom, we've just done a simple bar chart that shows the current state 100% stopped. And when we just look at separating internal from external, we see that 35% or 35 minutes out of 100 minutes can be converted to external. And that leaves you only 65 minutes of non-productive time. So this is step two. Step three now is we want to move internal elements to external. So our focus now is looking at your internal elements and saying, what can we do differently that might make those as potentials for external? So we challenge the process. I've given you some examples here. Presetting of tools offline. So you might go and purchase an optical presetter, and you can set your length and radius offsets to less than 1/1000th of an inch offline. You can preload the first part of a new batch already into a work holding fixture. You could add machine memory so that if you're running a computer numerical control machine, a CNC, you can actually download the next program while the current one is running. If you're in a press, for instance, then usually a press has access from two sides, and you can then load the press from both sides. So you can pre-align the next tool that goes in there. And as you can see on the smaller chart over on the right, we took another 10 minutes out of the 65 minutes and converted those to external. So instead of 100 minutes being the changeover time or setup time, we've now only got 55 there. Step 4 is to eliminate the waste from internal and external elements, because you really don't want to have waste in external either. Even though you do it while the machine is still running, it is still waste. So carry out a 7 waste exercise. Tim Wood, and all of you remember Tim Wood: transportation, unnecessary inventory, motion that doesn't add value, waiting, overproduction, producing more or sooner than the customer demands, overprocessing, using the wrong set of tools, systems, or procedures, and defects. So remember Tim Wood, and then carry out that exercise on the setup process. Obviously, you should focus firstly on internal elements, because they're just a waste of time completely. And some examples: standard pre-change kit lists and kitting trolleys, reduce the need for any hand tools that you might have, integrate into the equipment. So what do I mean by that? If you've got to use a wrench to tighten 3 or 4 different nuts, different size nuts, so you might need 3 or 4 wrenches, you might want to maybe weld a standard common size nut on top of the other one, so that all you've got to do is use 1 ring wrench. Use fender nuts, and for our English friends, those are wing nuts. Unfortunately, in the US, a wing nut is not a good term to use, but fender nuts, they help because you can spin them by hand. Try and perform operations simultaneously: 2-handed, 3-handed, 4-handed. Labor is cheap. You pay people anyway. If you have somebody just standing by a machine, watching or making sure that everything's okay, then there's lots of opportunities to utilize that time to come and help on a setup. Simplify your clamping so that you have maybe lever clamps, just 1 standard clamp to go on. And as I mentioned before, standardize your tool sizes. So you only need one wrench, and standardize where the locations of the tools are. When you're putting work holding fixtures in place, use stops and guides for alignment. And remove excess bolt lengths. I've got a paper towel holder in my kitchen, and it has a knob on the top. And when I purchased it to change the paper towel, I had to undo this knob maybe an extra inch than what was needed. So I went and cut off that extra inch, and now it's like 2 turns and it's off. It just saves time. So it makes sense. And I know I'm anal. So once you've completed the 4 steps, define your trial target. And then create a trial job detail and train the operator or the machinist to use it. So what do I mean by that? You've obviously converted a lot of internal elements to external. And now you've got a new process. You want to trial it to make sure that what you've agreed away from the machine actually will work. And this is the way to do it. So trial it using the standardized work combination table, and then you can see from the targets what you get. And you can reduce and reduce. Once you've done that, it's really important to standardize your new process, and then to monitor the ongoing setup times. Unfortunately, people, they're very simplistic. They will respond to what they're being measured on. Currently, if you don't measure changeovers, then they won't focus on making them quicker. If you do measure changeovers, then certainly there'll be a focus on making sure they're done to standard. I remember visiting a company in Guelph a few years ago in the early 2000s. They had a lot of CNC machines, and their setups varied between 3-4 hours, 2.5 maybe. And the general manager, he put a little visual into the company that said, when you start a setup, I want you to put a flag up. And I'm going to give you a little whiteboard. Tell me what time you start the setup. And we've got a target of doing everything within 2 hours. And the team leads constantly rotated around the floor, and they could see when the setup started. They look at their watch, they could see what it is now. They would ask the machinist, how are you doing? And because the people knew they were being measured and monitored, they focused on reducing those setups really, really good. So it's very, very important to do that. I'm going to show you a case study now. This is a company in the technology triangle, which is west of Toronto, Kitchener, Cambridge and Waterloo area. It is an automotive stamping company. They're a tier 2 supplier. And they did a value stream mapping exercise and determined that setup was a critical non-value added activity. Before they videoed the setup, they estimated that the changeover took about 2 hours. And when they finished video, the setup then was determined to be 114 minutes, so 1 hour and 54 minutes. We did a 4-step process at this company on this machine, and I'm going to show you a video that will show you what the result was afterwards. Okay? Sit back and enjoy. So you can see from that video that, in fact, there was a lot of improvement made to that particular job. Previously, it was 114 minutes, and then it was 8+ minutes afterwards. What did the situation look like before we started doing setup reduction on the machine? I've got some images here that will help show what it's like. If you look where the skip is, if you look at the conveyor that they used, it was really hard to get that conveyor in and out. It was really hard to get the skip in place. And then if you look at the chutes where they were, the chutes that were there were various chutes for different parts, and they were hung up on the end. So they had to go and decide which chute goes in which area or which part number and which die. Afterwards, they designed a really neat looking conveyor system that was on wheels, makes it mobile, and they could move it out and move it back in. Also, they numbered along the area, they numbered the bottom of the die where the table is, they numbered the slots. So that helped them as well. Beforehand, they got the chutes that were bolted down to the vibration unit. You can see the U channel at the bottom that they had, and there were bolts on there, and they had to obviously undo those bolts. And what did they do afterwards? They put a new vibratory unit on. They had die locating pins. They put nylon filler strips in the T-nut slots so that the slugs wouldn't go in there. And they had designed it so the scrap chutes could snap right onto the bar, and just like that. So there was no bolting and unbolting of them at all. They also dimensioned the dies. So these were the dies that they had, and it showed where the chutes went, the sizes. You can see the forklift locations are indicated where the green and the black arrows are, show the forklift driver knows where to pick it up from. And they did a lot of things to basically eliminate waste. This was the recordings that they did back in November, I believe it was 2004. So it just showed you which shifts were doing which things. Day shift were doing pretty good. Afternoon shift were a little bit less good because they hadn't practiced as much doing the changeover. These were the average times between shift 1 and shift 2. And as you can see, they got a trend of going pretty well down. So the second shift started to come into play February and March. So between essentially 9 and 13 minutes was their target for a changeover, as opposed to 114 minutes. So a huge, huge gain, a huge gain. So let's have a poll question. Okay, so here's our poll question that we're going to ask you all. What does SMED stand for? Does it stand for Save My Engineering Department, Senior Management Embraces Dollars, Single Minute Exchange of Die, or September Means Endless Delays? Dave, can you bring up the poll question for the audience, please? Okay, I think everybody's had enough time. Let's see what the results are. Here's the answer, single minute exchange of die. And what did we get for the results? Dave? Can you show the results, please? 100%. Perfect. Excellent. Okay. It was a little bit easy one, but it really sinks into your mind. So let's have a recap on SMED. What does it mean? Single minute exchange of die. And let's see, have we got the, can you see my screen again, everyone? I think so, yes. So the amount of time taken to change a process over from the last part of a production run to the first good repeatable part of the next production run. That's the definition. How do we improve that time? We perform a 4-step setup reduction activity. So step 1, capture the current situation. Years ago, we used to videotape. Now we just video. Step 2, separate your external from internal. So anything that can be done while the machine is still running, just separate it out. Step 3, convert any internal elements to external by ingenious methods, as you've seen on the video. And then step 4, go in even further to eliminate waste. And you noticed probably on the video they were using one size wrench, so all the bolts were standard and the wrench was right next to where they were going to use it. So they had one wrench either side of the machine. So a great example of setup reduction. And obviously, once you've done that 4 stages, you've got to standardize and make it current. So that then becomes the norm, and you follow the PDCA, continuous improvement process, plan, do, check, act, or adjust in order to get better. And that's what continuous improvement is all about. So that concludes part 1 of today's webinar, which was on single minute exchange of die setup reduction. Part 2 is about pull systems. Let the customer pull. And if you do your SMED correctly, you can then afford to reduce your batch sizes, and obviously don't inundate yourself with double or triple the amount of work order paperwork to fill in. You can look at many ways of maybe going electronic and not creating a whole additional load of paperwork when you reduce your batch sizes and run many more batches per week. So we say in Lean, every part, every day. Every part, every day. Every part, every day. Now, in order to control how those batches or one-piece flow goes through your system, we can introduce what's known as a pull system. So, what is push versus pull? Push, make all we can just in case, and pull, make what's needed when we need it. Wow. So what is a pull system? So this is a definition, a manufacturing system in which production is based on actual daily demand and where information flows from market to management in a direction opposite to that in traditional push systems. So if you think of a traditional push system, you might be running MRP. And MRP, Material Requirements Planning, or MRP2, Materials Resource Planning. You might be saying, well, I've got a firm order and I've got a delivery date, and I've got a routing, and I know how long each operation is supposed to take, and I calculate when I'm supposed to start each particular operation. So why isn't that pull? Because I'm doing it based on customer demand. Well, MRP will issue a work to list. So a particular work center in your organization, they'll print out a daily to-do list. And that's usually done on what's needed today or what's in backlog, what's past due. Do that first because it's late. And irrespective of whether the next process needs it or not, go do it. And essentially, you are now producing that work order on that machine, and you're pushing it downstream to the next process, whether they need it or not. The next process may have 2 weeks worth of queue in it. And that's no good, producing another one to add to the queue. It's just going to wait. What you really need to do is to say, okay, who are my downstream customers and what do they need next? And I'll produce that. And that essentially is what a pull system is. So it's a visible indicator showing what has to be produced and in what quantity. And we have a term there called Kanban. Next is a simple system that everyone can understand, and then also a flexible system that can easily adapt to changing conditions. So VisiFlex might be a good way of describing a pull system. It is not heavily computerized. It is not complicated. It is not based on sales forecast, and it's not run by office staff. It's run by the people who add the value, which are the ones that actually pay your wages. So these are Kanbans, and a Kanban is just a visual signal. So it's a signal to do something. It's a signal either to withdraw something from a supermarket, which we talked a little bit about in webinar session 1. It could be a signal to produce something. So now you got a signal to make something. But it's a visible signal. And it's usually used in conjunction with replenishment of items when they're being pulled to deliver to the customer. So this is Toyota Corporation. They designed the Kanban, and essentially it's a material requirements planning technique delivered by Toyota as a part of just-in-time inventory, in which work centers withdraw parts from feeding operations or supply bins. Kanban means a visible record, such as billboard, card, label, or sign in Japanese. So I'll remind you, this is a value stream map, and your information flows from top right to top left, and your product flows from bottom left to bottom right, and then gets shipped to the customer. So we might have a supermarket just before shipping that contains a certain amount of quantity of various different part numbers. When the customer orders, shipping will pull from that supermarket, and then a production Kanban is then sent upstream to the press, weld, and assembly cell, to manufacture another 250 and fill the gap that was left. The assembly cell would then send a withdrawal Kanban to a supermarket that is upstream from them and withdraw the necessary parts in order to make the 250 assemblies. Then there would be another signal that is sent to the stamp machine to replenish the 250 that has just been withdrawn, and then another signal sent to the steel supplier to replenish the coils that has just been used in the stamping machine. So this essentially is what a pull system does. The customer pulls the item off the shelf, and then signals go upstream to replenish. And it is a very, very good system, providing you have stable processes. So let's look at push versus pull. Pull is based on customer demand. Push based on sales forecast. Pull run by shop floor people. Push run by a computer, providing everybody's put the right data in. Pull, making very small batches. Push, run by economic order quantity, according to standard costing. And if you haven't done your setup reduction, you're probably going to run big batches, and you're going to clog up your flow line. Pull is visible to all employees. Push is visible to a few employees. So I've got a case study that I'd like to show you. It's a simulation. You're going to get this in the PDF handout later, but this will simulate how a pull system works. I'll give you a little bit of a background of this company. The initial situation, their inventory was not very good. Their finished goods warehouse was full. The aisleways were blocked with extra inventory. Work in process was clogging up the work areas. The raw materials were taking up lots of space. And the return areas was being overrun. So not a nice situation to be in. Lots of opportunity, though. Employees at this company. People were told what to do and when to do it. They were seldom asked what they thought about stuff. They were assigned to only one work area, and they were never involved in making any improvements. Again, great opportunity. Customer service, their on-time delivery was below 80%. Their internal quality was 89. Their external quality was 97, because they had a huge amount of inspection and sorting going on. And the lead time through the plant was 3 weeks. In operations, the setup times varied from 15 minutes to 2 hours. Maintenance was very reactive and not proactive or not additive. Scheduling was done weekly through MRP, and the production meetings that happened every day lasted as long as this webinar. They were very counterproductive. Declining dollar was increasing costs. Competition was getting tougher. Customers were becoming more demanding, and the US parent company made similar products, and margins were eroding. So remember that situation for the company, because we'll come to that again at the end. So what was their strategy? So they, first of all, developed a vision and mission and shared it with all of the employees. They trained everyone in the principles of lean, and they changed the thinking. So the leaders changed the thinking by walking and talking about an improvement strategy. And then they involved all employees in continuous improvement. They changed the way they measured. And they chose a pilot area and then started. So this was the pull system that they implemented. And it's going to be very visual. So try and keep up with me as I go through the sequences. This is a finished goods area showing 3 parts that are kept in stock. Part number 111 has 4 lots of a product, 222 has 2 lots, and 333 has 3 lots. This is the maximum inventory that can be kept in stock. Under each lot, there is a card or signal. You can see that by the yellow card. As one lot of product is sold, this card is sent to the assembly line to signal that a lot size of this product has been sold. This is the final assembly area, and it's represented by a table down which the parts will travel. Behind the assembly line, there's a board that has the following information: part numbers, X, which means a trigger point at which point production must take place, a cross, which represents an out-of-stock condition, the number of lot sizes that are in the system, the quantity that is in one lot size, and the average number of days of sales that one lot size represents. The parts and work in process are stored as close to the point of use as possible. These items are required to complete the final assembly of the 3 finished goods. So, in this example, we have 3 areas represented: a finished goods area, the final assembly area, and the parts and WIP supply area. So, sales will sell a 111. The card then goes into the rack, and a yellow dot is put in the first column of 111. Next, what happens? Another 111 has been sold. So another card is placed in the rack, and now a green dot goes over the trigger point. Now, in this particular case, 111 has 250 parts to be made, and the days per signal is 1. So there will be 4 days before they're out of stock. If you look at 222, okay, we have 5 days per signal, so there would be 10 days before they're out of stock. 333 has 3 days per signal, so there would be 9 days before they're out of stock. So that gives you an idea of which to do first or second. In this particular case, the signal is to pull the parts that make up a 111. So they manufacture from an 888 and a 666 in the paint department. And they do the assembly, and they provide it to finished goods. And the card goes back with the finished assembly. Next, sales have just sold 2 333s. Sorry, 2 222s. So now, I'm going to reverse back. sales have just sold a 111, so a card goes into the rack and a green dot goes on number 2 of the 111. But they've also just sold a 222, and the card now goes onto the rack and a green dot goes into the trigger point of 222. We now have 2 green signals. Which do we do first? So what you do is calculate the number of days supply in finished goods by multiplying the number of lots by the days per signal. So if you look at 111, you have 2 lots left in, which is 3 and 4 before you're out of stock. You multiply that by the days per signal and you get a quantity 2, or a new number 2. You look at 222 and you say, I have 1 signal, but 5 days before I'm out of stock. So 1 times 5 is 5. You now manufacture the lowest day's supply part. So you would manufacture a 111. So you'd pull a 555 and an 888 and produce it and put it into stock. You've now got a green signal that tells you that you've got a trigger point to make. But now you've still got 5 days left before you're out of stock. And in the 111, you've still got 3 times 1 and 3 days before you're out of stock. So in this case, because you're on a trigger point, you need to make a 222. So you would now take a 666 and a 777 and you would manufacture the 222 and put it into stock. Next, you've got a signal to produce a 111. So you would produce from an 888 and a 555 and put it into stock. Right. So now you've got a situation that it's 2 o'clock in the afternoon and you have no particular job to do. So what in fact would you do? What in fact would you do? Well, the answer is you would do anything that might benefit the business. A lot of companies would have the people maybe doing a 3-minute, 10-minute, 1-hour 5S activity. But what I like to recommend to organizations is that during the course of a workday, your employees who are on value-added activities have little or no time to think, especially about continuous improvement. So I would recommend that this is an opportunity to get the team or the individuals to think about continuous improvement and about what they could do to improve the situation. This is a great opportunity to get them to do that. As we progress upstream, the assembly line has been producing finished goods, so it's also been consuming WIP from the paint line. So the paint line pulls parts from fabrication, and the same rules apply to the paint line as they do to final assembly. So you prioritize based on customer demand. Now here, the 444 has again the number of days per signal, and you have 2 lots in there. So you've got 2 times 6 is 12 days worth of inventory in the downstream supermarket. The 555 has 4 lots of 2 days, so you have 8 days worth of inventory in the downstream supermarket. And the 666 has 2 lots of triggers, and the days per signal for each lot is 5, so 2 times 5 is 10 days worth of inventory. So again, you would follow the same sequence. You would work on the lowest. So I've now got only 1 day, 1 lot left, times 2 is 2. And on the 666, I've got 1 lot left times 5. So I manufacture the lowest part. And as you can see, we'd make a 555, put it into stock, take the card with it. We then make the 666, and then we put it into stock and take the card with it. We then proceed to make the 555s, because that's our signal to produce accordingly. So we again prioritize by customer demand. So again, now you've got 2 o'clock in the afternoon, and get your people with no demand to work on either 5S or thinking about continuous improvement. So now the fabrication department does the same thing. The same rules apply, and they get days per signal, and you base this on customer demand and calculate your days per signal accordingly and your lot sizes. And again, you work on the lowest number in order to produce, and that's your signal to produce. And if you have setups that you haven't reduced yet, then you can be flexible and keep the same setup to produce the part, as long as you're not impacting delivery to your downstream process. And if you're impacting delivery, then obviously you have to work accordingly. So the process happens just the same. And this was the results of their inventory at this particular company. So 77% reduction of A, and look at the inventory previously, 100,000 down to 20, 140 down to 42, 40,000 down to about 18, etc., etc., etc. Total reduction of inventory, 60%. Incredible. This is product B, finished goods inventory, and this is one final assembly line, and it shows how the inventory was reduced over a period of time. So starting target was 75,000, and they actually achieved below there. And this was a long, long time ago, 1994. But don't reinvent the wheel. These systems work really well. This is the this complements the previous graph and shows the increase in customer service over that period as well. So inventory level was going down and customer service was going up. The sales, the same happens now with production and finished goods inventory as it does for raw material and supplier. So what strategy can be used when dealing with your suppliers? So we look at the same sort of system and say, if it works for us, why can't it work for the supply chain? So here's the assembly line. We're taking parts and replenishing, and we need raw materials. We need raw materials, so exactly the same format is used to determine the criteria for signaling replenishment. So purchasing is monitoring the boards constantly. And when a change is made to the board, they advise the supplier. So once they've advised the supplier, they use a signaling sheet, and this signaling sheet could either be an email to the supplier, or in some cases, it could be a visible Kanban. So there might be a webcam Kanban or a web ban. I know of one company that actually has a complete supermarket that is covered by 8 webcams, and they have visible signals on that supermarket, and the suppliers who are bringing those parts into the company check the webcam every day through the internet, and they just supply a replenishment if it goes below the order level or the replenishment level. And then once a month they send an invoice in. So there is no purchase order, there is no receiving advice, there's no packing slip, there's no matching documents, and once a quarter the company does a quick check to see how much they would have used over that 3-month period, and if it's within 5 to 7%, they just pay the invoice. An enormous amount of administrative chores that are eliminated. So here's your signal sheet that gets sent to the supplier, and this is obviously multiple part numbers that go through, and it's sent by email to the supplier. The supplier then manufactures and delivers back to the plant, and all of the magnets are removed, and the cards are then placed with the goods back into the storage. So, inventory on purchase goods, again, we see a tremendous reduction from the current inventory prior to Visiflex down to the Visiflex system, 32% again. So, the initial situation on inventories, finished goods warehouse was full. Now, 60% reduction. Aisleways in warehouse were blocked. Now they're cleared. WIP was clogging the work areas. Minimal WIP in the work area. Raw materials were taking up excessive space, reduced by 32%. Returns area being overrun, and it was now converted into an R&D area. Employee involvement, people were told what to do and when to do it. Now people are coached to accept empowerment. They were seldom asked their opinion, and now they're involved in the changes. They were assigned to one work area, and now they're cross-trained. And they were never involved in making improvements, and now they're always involved in making improvements. Customer service, their on-time delivery was below 80, it's now 96.5. Internal quality, 89, now 97. External quality, 97, now 99.5. Lead time was 3 weeks, now it's 2 days. Incredible. Operations, setup times varied from 15 minutes to 2 hours, now 0 to 15. Maintenance was reactive, now preventative maintenance on key equipment. Customer requirements met by scheduling, and now it's met by a pull system or Kanban, and the daily production meetings from 90 minutes down to half an hour, and are very proactive. Company, declining dollar was increasing costs, doesn't change. Competition was getting tougher, didn't change. Customers becoming more demanding, didn't change. US parent company made similar products, didn't change. Margins were eroding, margins are improving. So, a poll question. A production Kanban is a traditional work order or a card that is sent to production control, or a signal to production to start working, or a signal to upstream operation that more work is required. So, David, can you bring up the poll question, please? And we'll give everybody a few seconds to answer it. Is it 1? Is it 2? Is it 3? Is it 4? What is a production Kanban? All right, close that down. David, let's have a look at the answer. And the correct answer is a production Kanban is a signal to start working. So we had, 55% said that a signal to upstream operation that more work is required. 36% a signal to production to start working. And 9% a card that is sent to production control. Okay, so that's interesting. So a production Kanban is a signal to start working. It's a signal to production to start working. I have to start working. So it's like those discs that are put onto the board. That is a signal to start producing. Okay, so I put that one in as a little bit of a teaser for you. A signal to an upstream operation, yeah, that is correct, but it may not be the right one for a production Kanban. So number 3 is the correct answer. Okay, thanks, Dave. All right, so let's have a look at some rules that we put in from a pull system. So number 1, include everyone in the process, both customers and suppliers. Don't send defective parts downstream. You should never do that. Pull systems require reliable equipment, stable processes, and they work better on products with stable month-to-month requirements. Suppliers should deliver materials or parts to point of use, and Kanbans should be returned to the supplier immediately. Do not overproduce and produce based on the appropriate schedule that has been developed. Determine all non-value added activities and try to eliminate them, i.e. setups or transportation. And then finally, continue to adjust the number of lots in the system to reduce the lot size. Continuous improvement. Other types of signals that you might see beside cards, lights, dedicated floor areas. So if you've got 3 spots in front of a piece of equipment, if you've got an empty spot, that's your signal to produce. You might have level indicators on tanks, marks on walls, or on racks or containers, etc. Looking at continuous improvement with pull systems, the following continuous improvement tools can be used: SMED, setup reduction, plant layout to improve flow, workplace organization, 5S, preventive maintenance so you don't become reactive, cross-training of employees, and both supplier and customer relations are very, very important. So, any questions? We've looked at SMED today, and we've looked at also pull systems as well. So let's see if we've got any questions. David, any questions?
Thank you, Richard. If you have any questions, please submit them on the right side of your screen. Here's one, Richard. What if setup takes more than 1 shift? Would you still video it?
Yes, absolutely. You've got to see it in its complete entirety in order to make sure that you capture all the elements. If you've got a whole shift dedicated to a setup, obviously it's a pretty complex setup. If you're going to reduce that, you have to make sure that you get all of the elements and identify them before you can then separate the external and internal, David.
Thank you. And one other question, do you have any examples of electronic Kanbans?
I gave one already, which was like a webcam that a company uses, and that's a really powerful one. There are other examples. I've seen companies where at the supermarket within the pull system process, the operator or the machinist has the ability to go to a screen, and then essentially if he's pulled out a lot to produce in, say, a downstream process, then he can go and immediately click a link or tap the screen. It will send a replenishment signal to a supplier to immediately come and replenish what he's just withdrawn. So any types of electronic means of sending that signal is there. There's also lighting as well. You might have lights that the downstream operator has signaled, and a light will come in your area, and that will be an electronic signal for you to produce as well.
Okay, thank you, Richard, for a very insightful presentation. This brings our webinar to a close. Our fourth scheduled webinar in this series will be on Thursday, January 5th, titled Head Towards Perfection with